In this video, we will use a standard technique to evaluate several more trigonometric limits. And let me give a reminder from a previous video, two special trigonometric limits that we encountered. The limit as x approaches 0 of sine x over x is equal to 1. And additionally, the limit as x approaches 0 of 1 minus cosine x over x is equal to 0. And if we now compare back to the function which we are evaluating the limit of, notice that 1 minus cosine x and the sine x match up with the numerators of these two common or special trigonometric limits. But what we need is to divide by x in both of them. And that's the exact intuition that we need. One thing that we can always do is multiply by 1. So we will multiply by 1 over x divided by 1 over x. So we're just multiplying by 1 in a fancy way. Then this becomes the limit as x approaches 0 of 1 minus cosine x divided by x, all divided by sine x over x. And because we know the limit in the bottom, that would be the limit as x approaches 0 of sine x over x, is not 0, it's 1, we can apply our limit laws and take the limit of the top, so that would be 1 minus cosine x over x, and divide that by the limit in the bottom. And using the values that we have to the right, the limit in the numerator is 0, and the limit in the denominator is 1. And the expression 0 over 1 is simply the number 0. So the common technique that we've used here is that we recognize the form of these special trigonometric limits, and we multiplied by 1 in the fancy way, 1 over x divided by 1 over x. So let's go ahead and evaluate the limit as x approaches 0 of sine 4x divided by tangent x. And let me once again remind you of the special trigonometric limit, that the limit as x approaches 0 of sine of cx divided by cx is going to be the number 1, and this is for any constant c. So from the expression that we have, we note that we would really like to be dividing that sine of 4x by a 4x, but then the question becomes, what do we have in the denominator? So before doing that, let me just simplify one step. I cannot directly apply x equals 0 because tangent of 0 is 0, and the expression would be undefined. But what I can do is rewrite tangent as sine over cosine. So this will become the limit as x approaches 0 of sine 4x divided by sine x over cosine x. And let's go ahead and add in the x in the denominators that we would like to see there so that we can work towards this special trigonometric limit. So we will multiply the top by 1 over x and the bottom by 1 over x. So in the numerator, we have sine of 4x divided by x. And in the denominator, we're going to have, I'm going to break it up and write it as sine x over x, because that's something we've seen we can work with, multiplied by 1 over cosine x. So now if we think about letting x approach 0 in the denominator, the sine x over x term is going to go to 1, and 1 minus cosine x is going to go to 1 over cosine of 0, and cosine of 0 is 1. So now that expression in the bottom is going to be defined, and we can go ahead and apply our limit laws. So we'll have the limit of the top divide it by the limit of the bottom. And in the bottom, it's a limit of a product, so we'll make it the product of the limits. The limit of the first multiplied by the limit of the second. So looking at the resulting limits, what we need in the top is to divide by 4x. So as in the previous example, we will multiply by 4 as well. We'll pull that 4 in the top out front, and we will have 4 times the limit as x approaches 0 of sine 4x over 4x. And in the bottom, the limit as x approaches 0 of sine x over x is the number 1. And the second limit is a limit of a quotient, so we'll take the limit of the top, divide it by the limit of the bottom. And for our last step here, the limit that remains in the top is 1. In the bottom, the limit of a constant is a constant. And the limit as x approaches 0 of cosine x is cosine of 0. So cosine 0 is 1. So we're dividing by 1. And what we end up with is 4 divided by 1, which is the number 4. So one very good observation to make at this point is not every limit is going to work out extremely quickly or efficiently. Sometimes we will have to take multiple steps and do different types of algebraic manipulations or different types of limit law applications throughout. So they require both patience and oftentimes a bit of perseverance.